So this is a pretty straightforward vectors question from Pearsons Ed Excel International paper June 15. It all boils down to the definition of dot product, which I've written here. Beyond that, it really is a trig question, really. We've got A dot B, which we're told is 20. Mod A, which basically means magnitude of A or length of A even, is 5. Mod B, magnitude or length of B, which is 6. Cos theta. So there we go. Cos theta is 20 over 30, which is 2 over 3. That's it. Nothing more to it than that. So part B, as I said, it really boils down to trig now. So the cosine rule states that a squared is equal to b squared plus c squared minus 2bc cos A. Well, in this context, we're looking for, let's write ab squared is equal to b squared, which is 6 squared, plus c squared, which is 5 squared, obviously changing around the letters, minus 2bc, so that's minus 2 times 6 times 5 cos A. Now cos A is 2/3. I hope no one's used a calculator at this point, because really we don't need to work out the angle. At no point has it said work out the angle. So I'm going to cancel the 3 there with the 2 there. And that gives me AB squared is equal to 36 plus 25. And this all multiplied out comes to, that becomes 4 times 520 times 40, so that's minus 40. So that gives me AB squared is equal to 21. It wants the exact length, so it doesn't want us to actually quote this to a certain number of significant figures or anything. Square root of 21. Like I say, just cosine rule. You could, but incidentally, if you'd spotted it, saw this in the mark scheme, I didn't spot it myself, and I've spotted that that is actually the dot product of their 20. So 20, you could have gone directly to just replace BC, this bit here, with 20. It would have been slightly less of a calculation to do, so basically we could have replaced all of this bit with 20, because that is the dot product. If you work it out, it would be C. So we had 40 here, for example, which is 2 times the dot product. So I've made it even quicker if we'd spotted that, but never mind. So, part C. So that the area of the triangle OAB is 5, the square root of 5. Well, we've got a formula for the area of a triangle, which is, if you know the two sides either side of it, if you know the length of those two sides, we can work out this length. Sorry, it's not the length. We can work out the area by doing half times the two sides in between, where the angle is in between. So it's half times by 6 times by 5, two sides, times by sine theta. I suppose the only thing is we need to show it is exactly 5 square root of 5, so we need to state what sine theta is, because we know cos theta. Now I prefer, we can use trig identities here if we want, but I prefer to do a quick diagram with a triangle, because we're only dealing with obtuse angles after all. So we've got 2 and 3. If I set my hypotenuse to being 3 here, and my adjacent being equal to 2 there, I can see that this is the square root of 5 here. So sine theta is equal to the square root of 5 over 3. You may prefer to use trig identities if you want. Okay, so that sine theta is square root of 5, and we're nearly there. Area equals to half times, just write the whole thing out again. Okay, I'm going to do a bit of cancelling. I like cancelling. I try to avoid as much as I can with the calculator there. There we go. Not bothered with the calculator. That gives 5 the square root of 5 as required. Really need to be bagging those marks, folks. That was not difficult. Cheers.